And so then you get really interesting questions like, well, how? Because the radiation that comes, first of all, Stephen Hawking's calculation said it doesn't, right? So there's something wrong with the calculation. And secondly, the way it's produced. The interesting thing about Hawking radiation is that how does it, you have to think, just to step back, a black hole in Einstein's theory is described as pure space-time, right? It's just space-time geometry. This radiation is coming from what's called the event horizon of the black hole, which is just space. So it's almost as if a way to think about it is the black hole is kind of shaking or tearing this radiation out of the vacuum of space. It's coming from the vacuum. It's not coming from the thing that fell in, right? So the question is, if something goes in and then this black hole disappears and all the radiation has come from something to do with the event horizon and the vacuum of space, how can it be that this thing that fell in gets imprinted in it? And that's where the recent calculations, I mean, very recent in the last few years, have suggested the information comes out. And then the way it comes out, this is active research. But as I mentioned earlier, one picture, which is very speculative, is that some kind of wormholes, some sort of wormholes, not the Einstein-Rosen bridges, by the way, some other kind of open up from the interior of the black hole to the exterior. And somehow the information comes out through wormholes. But that's very, very a speculative interpretation of some difficult mathematics. And there's no consensus on that. It's very exciting because what it's actually doing is it's showing us a glimpse of a deeper theory of space and time. On that, I think most physicists agree. But what we're glimpsing, I don't think most physicists agree on.